Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we write a Java program to model a fraction in a class using oops. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 1 or 2 are subscribed and a subscription is very important. So please do subscribe to my channel. Let's begin. So we know a fraction is made up of a numerator and denominator. So I am going to take two private members, private int numerator and private int denominator. Okay, so I have a fraction class here, I have a test fraction class here. Here I'm going to create objects and call functions and test the fraction class we have written. Okay, so in order to create a fraction, we need numerator and denominator. Two private members I have taken, so I add a constructor public fraction takes in the numerator and the denominator. Okay, sets this dot numerator to numerator, okay, and sets this dot denominator to denominator. Okay, so I can create a fraction in this main. I can say fraction, okay, f1 equal to new fraction, and I pass numerator as 2 and denominator as 3. Okay, so this is creating a fraction f1 equal to 2 by 3. Okay, but how do I print this? So in order to print this fraction, I will override the toString function. I will say public string toString. Okay, does not take any parameters, and this is the exact signature you need to write when you are overriding toString. And we are able to override toString because toString functions are implicit parts of any class you create, because any class that you create in Java is a subclass of object class that has a toString function. Okay, so how do I want to print my fraction? I want to print my fraction as, say, example, numerator equal to 2 and denominator equal to 3. Print it as 2 by 3. Okay, so I return, okay, blank plus numerator plus a slash plus a denominator. Okay, so in my main I'm going to do sysout, okay, f1 equal to plus f1. Okay, so when I do something like this, the toString method is implicitly called, that is, this is equal to this. Okay, so we don't need to write this, toString is called, so we get the value of f1. So I'm going to run this. So f1 is 2 by 3. Okay, let me create a few more fractions. I'll say 3 by 4. So f2 is 3 by 4, this is f2. Okay, f3 is 10 by 4. So I print f1, f2 is 3, f2, f3, f2, f3. Okay, running this. Okay, so f1 is 2 by 3, f2 is 3 by 4, f3 is 10 by 4. But this fraction is not into the lowest terms. Okay, so this is equal to basically 5 by 2, in which I want to represent this in the lowest terms. So what I do is I add a private void reduce. Okay, and this is going to reduce my fractions into the lowest terms. So how do I reduce the fraction to lowest terms? I find the HCF of numerator and denominator, and I divide numerator and denominator each by HCF. Okay, so I write another helper method to find HCF of numerator and denominator. So I'll pass, say, int a and int b. Okay, I'm going to use the Euclidean method to find the HCF of two integers a and b, and I have already posted a separate video that explains how to find the HCF of two integers. It covers the brute force method and this Euclidean method. Okay, I will add the link of that video in the description. So the code for this is very simple. If a equal to 0, return b. Okay, otherwise you call this recursively, pass b%a and a. Okay, so when I need to reduce, I find HCF of a and b as passing numerator and denominator. Okay, and I say numerator is numerator by HCF. Okay, and then I say similarly for denominator is denominator by HCF. Okay, and I call this reduce whenever I create a fraction, because I want the fraction in the lowest terms. Okay, right, let me run this now. Okay, so I get 5 by 2, okay, instead of 10 by 4. Okay, there's one more thing I want to change is basically, so this is an improper fraction. I want to print this as mixed fraction 2 whole 1 by 2. So I update this toString as I say if numerator, okay, is greater than denominator, that is if it is an improper fraction. If it is an, okay, print it as a mixed fraction. So I get the whole part as numerator by denominator. Okay, just the quotient I get in numerator, and this is the numerator for this updated fraction. Okay, so this is equal to this dot numerator percent denominator, and you return whole part, okay, plus the updated numerator by the denominator. I'll close this. So basically, example, numerator is equal to 5, denominator equal to 2, print it as 2 whole 1 by 2. Okay, so when I run this, I get 2 whole 1 by 2. Alright, okay, let me create another fraction, say 11 by 3, okay, f4, and I print f4. f4 is 3 whole 2 by 3, 3 share 9 plus 2 11 by 3. Okay, then we create another fraction, say I create f5 as 7 by 7, okay, and as f6 as 6 by 1. Okay, so let me print f6 f5. Okay, so for f6 I get something like this. I don't want something like this. I want 6 by 1 to be just printed as 6. Okay, and for f5 I'm getting 1 by 1. I just want this to be printed as 1. So let me just fix this part first. Okay, so if my denominator is 1, I just print the numerator. Okay, so if denominator equal to 1, I simply print the numerator. Okay, if the denominator, okay, so when I run this, I get 1 and 6 now. Okay, which I expect. Okay, 7 by 7 is 1, this is 6. Or if I want a fraction as 6 by 1, I should simply be able to say 6. So for this I add another constructor. I say public fraction that takes only the numerator. Alright, that's numerator to numerator and denominator to 1. Okay, so now this is valid, which is equal to 6. f7 is 6. Alright, okay, so if I create another fraction, say f8, okay, that is 0. Okay, f8 is 0, it should just give me 0. If I say if f8 okay, if I have f9 as 0 by 10, okay, so I should just get 0. Let's see. Alright, okay, in this I should not be allowed to divide by 0. I should not be allowed this. f10 is undefined, so if I print f10 now, I will get an exception, okay, which I get here. Okay, alright, so when you are creating this, you simply say if denominator, okay, equal to 0, okay, throw new arithmetic exception. Okay, denominator cannot be 0. Alright, so when I run this, I get arithmetic exception. Okay, so I will not be needing f10. Alright, so we are able to create fractions and print them. So now let's just add some functions. So I will add the first function to add two fractions. I'll say add fraction RHS. So add this to RHS and return the sum as a new object. Okay, so return new fraction, okay, with numerator and denominator. Okay, so if we have two fractions, f1 equal to a by b and f2 equal to c by d, we have f1 plus f2 as ad plus cb as numerator and bd as denominator. Okay, so b is going to be this dot denominator and d is going to be RHS dot denominator. Okay, a is going to be this dot numerator and d is going to be RHS dot denominator, plus c is going to be RHS dot numerator into b is this dot denominator. Okay, so this is the numerator part that we are passing, this part, and this is the denominator part. Okay, alright, so let me test this. Okay, so I'll say system.out.print f1 plus f2 plus equal to plus f1 dot add f2. Okay, f1 f2 we can do f3 f4 f3 f4, and this is going to return a new fraction object which is going to be the sum of f1 and f2, that is we print similarly for this. Okay, so let us run this. So we have 2 by 3 plus 3 by 4 is 1 5 by 12, which is equal to 12, yeah, 17 by 12. Okay, 5 by 2 by plus by 11 by 3 is this 37 by 6. Okay, let me add another case, f5 f6. Okay, f5 f6. So 1 plus 6 is 7. Alright, so we were able to add this add functionality for two fractions. Similarly, we can do subtract. Okay, so if f1 is a by b and f2 is c by d, f1 minus f2 is ad minus cb by bt. So we just replace this plus by minus. Okay, alright, and need to change this method to subtract RHS from this, return the difference as a new object. Okay, so I will copy these. Okay, I'll paste it here, minus 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 subtract 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 subtract. Okay, running this. So 2 by 3 minus 3 by 4 is minus 1 by 12 and minus 7 is inside. Okay, similarly in this case. So now we need to fix the printing so that we get the minus signs output correctly. Okay, so how do we handle the minus signs? So when we are handling the negative signs, we adjust the signs in reduce. How? We calculate the HCF based on the absolute value. So I say math.abs. Okay, and I pass numerator, and then I do math.abs, I pass denominator. Okay, right, then update signs. So if numerator is negative, if numerator is less than 0, okay, and if denominator is also negative, denominator is also less than 0. Okay, in this case what is happening, minus minus signs are getting cancelled. So I say numerator is minus numerator, you make numerator positive, and denominator is minus denominator, you make denominator positive. Okay, and else part is going to be when denominator is greater than 0. So for numerator less than 0, denominator greater than 0, we are okay because we want the negative sign to stay with the numerator. Okay, right, so I'll say if it is there and denominator positive. Okay, else if numerator is positive and if denominator is negative, in that case we want to transfer the signs because we want the negative sign to stay with the numerator. So I do the same thing, numerator becomes negative, denominator becomes positive. Else part would be when denominator is also greater than 0, in that case we don't do anything. Alright, and that is how we adjust signs in our reduce function. Alright, so let me add a few more cases. I'll say f10 equal to say 10 by minus 9, and I print f10. Okay, so I get f10 as minus 10 by 9, which is okay. Alright, if I add minus 8 by 20, okay, this should be equal to 8 by 20 because minus minus signs cancel, which should be equal to 2 by 5. 4 2 is 8, 4 5 is 20. This should be your f11. F11. So when I print f11, I should get 2 by 5. Okay, cancel the signs and get to lowest terms. f11 is 2 by 5. Alright, and if we have the other way, minus 8 by say 7, it should stay minus 8 by 7. Okay, because the negative sign is with the numerator. Okay, and it is already into the lowest terms. So I print f12. Okay, f12 is minus 8 by 7. And you see, when we handle the negative signs, that is we want the negative sign to stay with the numerator and denominator is always positive in case of negative. So this is okay, but we need to do some more changes so that this is printed as minus 1 1 by 6. Okay, so we update the toString now. So we add one more case if numerator is negative, because if the fraction is negative, minus sign is with the numerator, else if numerator is less than 0. So we have two options, print as mixed fraction or print as proper fraction. Now printing as proper fraction is possible if absolute value of the numerator, okay, is less than the denominator. So we simply do this thing, okay. Else is the part where you print as mixed fraction. So we need to print the negative fraction as a mixed fraction, okay. So we need to get the whole part, the updated numerator and the denominator. So we can use this exact same thing, but instead of numerator I will use mat.abs of numerator and mat.absolute dot numerator, okay, and we just add a minus sign, okay. So minus sign, whole part, numerator, denominator, and this is always going to be positive because we are calculating it using the absolute part, and denominator is always positive, okay. So when I run this, you see we get minus 1 by 6, okay. So we are able to handle the negative signs, printing them as proper fractions. All right, we move on to the next method, which is multiply. So this is also going to be very similar. If f1 is a by b and f2 is c by d, then f1 into f2 is very simple to calculate. This is equal to ac by bd. So you say multiply, okay, multiply this to RHS and return the product as the new object. So this dot numerator into RHS dot numerator and this dot denominator into RHS dot denominator. That's it. Okay, multiply numerators, multiply denominators. Okay, so let me see. Let us test this. F1 into F2, 3 into F4, F5 into F6 dot multiply, copy, V. Okay, so 2 by 3 into 3 by 4 is going to give us 1 by 2, 5 by 2 into 11 by 3, 55 by 6. 1 into 6 is going to give you 6. Okay, we can do one more case. F7, F8, F7, F8, 6 into 0 is 0. Okay, similarly we can do the divide function. This is going to be easy as well. So public void public divide, okay, divide this by RHS and return the result as the new object. F1 by F2 is going to be AD by BC. AD, so D is RHS dot denominator, okay, and RHS dot numerator into, okay, AD, this is AD and this is BC, okay, F1 by F2. So let us test this. So F1 by F2, okay, let's say divide, copy, paste, paste, paste. Okay, now is F8 0? F8 0 is not allowed, we should get an exception. Okay, so we get an exception for this F8 case, this one. Okay, this is not allowed. Nice. So we run this again. So 1 divided by 6 is 1 by 6, 5 by 2 divided by 11 by 3 is this, and 2 by 3 divided by 3 by 4 is 8 by 9. Okay, so what more functions we can add? We can add another function to get the value, that is the value in decimal points. So we can say public double get value, okay, return numerator by denominator. Okay, so I'll say f1 equal to f1 dot get value, f1 plus, okay, f1 f2 f3 f4 f2 f4. Okay, so we get 2 by 3 as 0. Now can you tell me why this is happening? Okay, and we are not even getting the decimal places here because we are doing integer division here. Integer by integer will always give you the quotient, it will leave out the remainder. So if you want to get the result of this as a double type, you have to either change the numerator to a double type or the denominator or both. So I'll show you. 1.0 into numerator, it becomes a double value by integer, which gives you a double value. So we get the right output. Okay, 3 by 4 is 0.75, 5 by 2 is 2.5, and so on. Okay, if I do the same thing for denominator, okay, and leave the numerator as an int, I will still get the right value, because one of these two has to be a double value, get the right value again. Or if we change both to a double value, still we get the right output, because double by double is a double. Okay, so multiplying it by 1.0 is one way of making it a double value, or you can say double typecast. Okay, double of numerator, and this is still going to work. This says treat numerator as a double, okay, which you get here. So double by integer. Okay, you can choose any of the. Okay, so just remember to make one of the numerator or denominator to a double type and avoid integer division. Okay, what more functions can we add? We can add public boolean equals. This is basically to check the equality of two fractions. Alright, and this is also a method of the object class. That is, we need to override this method. Alright, just as we did with toString. Just add it with toString, right? You can see this override symbol here. Okay, so I say if other equal to null, okay, return false, because if I compare a non-null object with a null, I should get false. Okay, if other instance of fraction, I can only compare this with another object if this other object that is passed is a fraction, else return false. And this is a very standard check, a very standard way to code equals method. We get the other fraction in that variable, I say fraction of other, we typecast. Alright, and then we compare numerator and denominator. We say if this dot numerator equal to that dot numerator and this dot denominator equal to that dot denominator. Right, so for this and RHS to be equal, they both have to have the same in numerator and denominator. Okay, and we are making sure that numerator and denominator are reduced to lowest terms and the negative sign is always with the numerator. Okay, so let me test this. So I'm going to create F13 as and F14 as. So F14 should be equal to F11 and F12 should be equal to F13. Okay, so I'll copy this. Okay, so I have to check F12 equal to F13, F12 equal to F13 plus dot equals F13, and F11 equal to F14, and I can add F12 plus equal to plus F13. I'm creating output in two different formats. Let's see which looks better. Okay, so F12 equal to F13 minus 1 by 7 equal to minus 1 by 7 true. Okay, all right, so I can remove this. Okay, and F11 is equal to F14 is true, so I'm going to print F11 F14 comparison in the same previous format, F11 F14 F11 F14. Okay, okay, so if F11 is 2 by 5, okay, F11 is 2 by 5, F14 should also be 2 by 5, which is true. Okay, we have F12 as minus 8 by 7, F12 is minus 1 by 7 in the mixed fractions, and similarly should be F13, which is true. Okay, moving on to the next thing we can do with this fraction class is compare two fractions by implementing the comparable interface. I'll say implements comparable, so it should be comparable to another fraction type. Okay, so we have to override the compareTo method. Okay, this compares two fractions for lesser than, greater than, or equal to. Okay, so if this fraction is less than this fraction which is passed, so I'll say that. Okay, then you return a negative value which is less than 0. If this fraction is greater than that fraction which is passed, you return a value greater than 0, else you return a value equal to 0. Okay, so how do you compare two fractions? We use the get value method. So I'll say double this value is this dot get value. Okay, I'll say double that value is that dot get value. Okay, so if this value is less than that value, okay, return minus 1. Okay, else if this value is greater than that value, return positive value which is 1, and finally return 0 for equality. Okay, and since get value method is using numerator and denominator to calculate, and we make sure if two fractions are equal, the numerator and denominator will be same, so this equality is going to work. Okay, so let me just compare now. So I'll add, so I'll take this, paste it here. So I'll say f1 is less than, gives you a value less than equal to 0. Okay, running this. So 2 by 3 is less than 3 by 4, 0.6 is true. 5 by 2 is less than 11 by 3, true. 1 is less than 6 is true. Okay, if we reverse the signs, okay, if I say greater than and greater than, okay, compared to f2 is greater than 0, greater than 0, greater than 0, so all comes out to be false. Okay, we can take another case, f7, f8, f7, f8. Don't know what those values are, but let's see. f7, 6 greater than 0, f7 is 6, f8 is 0. All right, so one more thing we can do is create fractions out of strings. Okay, so if I want to create, say, maybe a fraction f15, okay, I want to say this is equal to 8 by 20. Okay, so I should be able to create a fraction using this string which has the fraction passed as a string in proper format. Okay, so I add another constructor. Okay, I say public fraction string. Okay, the first thing we need to do is find the slash index. Okay, so I say int slash index is s dot index of slash. Okay, the part before the slash index is the numerator, part after the slash index is the denominator. So I say string numerator part is s dot substring. Okay, starting from 0 till slash index. Okay, and similarly the denominator part is s dot substring starting from slash index plus 1 till the end. Okay, and I create a fraction by passing this as numerator and this as denominator. Okay, so I said this dot numerator is integer dot value of numerator num. Okay, and this dot denominator is integer dot, and I say reduce. Okay, so I should be able to get 8 by 20 in f15. I say f15 should be 8 by 20. F15 should be 8 by 20, which is 2 by 5. Okay, I should be able to get, say, 4 by 2 as f16. F16 is 4 by 2, which is basically 2. F16, F16. Running this, F16 is 2, which is correct. Now what if I want to pass something like this? F17 is 4. F17 is 4. Okay, F17. Okay, so in this case I want to handle no slashes because there is no slash. Okay, so this is the case where I have if slash index equal to -1, if there is no slash. If no slash, this is a whole number. Okay, else this is a fraction. So I take this as blank, I take this as blank. Okay, and I have to remove this. Okay, so in this case, when there is no slash, your numerator is this entire string and your denominator is 1. Okay, otherwise in the else case, if you have a slash, you get numerator and denominator like this. Okay, and then you set the numerator and denominator for this class. Okay, so now when I run this, I should be able to get f17 as 4. F17 as 4. All right, you can also do f18 is, say, maybe minus 5 by 9. F18, F18, F18. Okay, so when I print this, F18 is minus 5 by 9. And even if you keep the negative sign on the other side, this should be okay. F19 is minus 5 by 9. Okay, so F18 and F19 should be equal. F18, F19 should be equal. F18, F19 F18, F19, F18, F19 is equal. Alright, okay. So we can add one more case, okay, where we pass some gibberish inside. So that case is not very necessary here. You should be able to just extract fractions out of this string format, okay. And if you want me to add the code for handling any garbage string, I can add that as well. All right, this video is already pretty long. All right, so this was the solution to model a fraction class, okay, and I hope this was helpful. So if you like this video, if you found this helpful, please subscribe to my channel. And if there was something that you did not like about this video, please just don't press the dislike button. Please also let me know in the comments what was it that you did not like about this video, so that I can improve in my further videos. And you can also let me know in the comments if there is a question you want to solve or if there is a concept you want to discuss. Thank you.